Hi friends, welcome back. So today we have another video on a recommendation system, that is on song recommendation system. So basically, as I said, we'll be coming with some use cases as well, like how we can apply the content based filtering or the popularity based recommendation system in the case studies. So today we will see one example of song recommendation system. Let's say there is a website or there is a songs websites, and like YouTube music we can say, or take it YouTube, like itself YouTube. So when we play a song, we listen it. So next time, as I said, that we get the recommendation, okay, this is similar to this song, so would you like to listen to it all as well? So that kind of thing. So what we'll do is we will first try to understand the problem, then we will discuss the steps, how we can divide the problem into the step, and how we can frame the recommendation system for it. So the problem statement we have is, a lot of company worldwide recommends a song to listener based on their interest, right? Some popular example of such companies are Spotify, of course, iTunes, Ghana, Savan, etc. Song recommendation helps user to discover new artists that make music similar to the genre which they listen to. This help in increasing revenue across these platforms and helps artists make a survival by streaming their music online. As part of this exercise, we will be build a recommendation system that recommends a list of song based on user song preference, right? So these are some attribute information like what we have in the CSV. So basically we have two CSV, right? One is a song CSV and another one is song extra info CSV. So the extra info basically contain the extra information about our main CSV. So although I'll be provide the CSV as well. So these are some content, like how we will frame this, like importing library, setting option, read data, then we'll do exploratory data, pre-processing, then check shape, check for missing value, sample only 10,000 data points from the used data set, content based recommendation system will apply here, of course, and finally the conclusion. So these are the steps and details. So if you want to read it, if you want these for your notes or know your college project, so we have made this step properly in written, so how you can do the song recommendation system by yourself. So first go through with these steps and then try to frame the problem with the given case study. Basically we have done this on Google Colab, so we are mounting the Google Colab. Now import a required library, so pandas as pd, numpy as np, and matplot.pyplot as plt, matplot inline, os, glob, right, seaborn, label encoder we are doing it for pre-processing, zip file, of course. We'll be using tfdf vectorizer and count vectorizer. Similarly, we will do linear kernel cosine similarity, as I described what the cosine similarity in the last video. So if you have checked that, then it is great, and if not, please check all the video in this series. Now we have filter warning to ignore all necessary warnings and logs, so we are importing warnings, right, to ignore these. So setting the option, so here you can see that how we have divided the problem into steps. So this will help you to better understand the recommendation system, so that you can easily use it in your daily life problem or your projects. So setting option, of course, suppress display of warning, so ignoring all these. So display all data frame columns, okay, so we are doing it as none. Now to set the limit to 3 decimal, so we are using this format. Display all that data frame rows, so max rows equals to none, like max column we have. Now we are we move to the directory. So if you are working locally, so you can easily access these data set directly. So third step is our read data, or EDA, exploratory data analysis. So read the data file pd.read.csv, song.csv, encoding it is in Latin, then pd.read.csv song extra info.csv, encoding in Latin language. Now check few rows of the imported data set, so songs.head. So here you can see that we have song ID, length, genre IDs, artist name, composer, lyrics and language, but here you can see that our data is not well no structured. So again, what we'll do that we will do the data pre-processing and EDA. So first checking the shape. So this is the shape and this is the info of shape. Now checking the column in each data frame. So song.column, info.column. In song.column we have these, in info.column we have these. Now we will merge both the data set into one data set, so we'll get what, DF, and we are merging both on the basis of this common song ID column. Now df.column, so we got all the column together. Make copy of the original data frame. Of course we do not want to lose anything in the series. Now df composer equals to df composer dot drop. So we are dropping df composer dot column difference, cause song ID, name and composer. Now df composer dot save, if we get it, so we have this save. Check the data type, song ID, name, composer, right? Now df composer dot head, so if we get the head, so song ID, name and composer, we have these three main column. Now checking the missing value. So number of missing value in song ID it is 0, in name it is 2, but in composer you have seen there are many missing records in this, right? So let's drop the missing values. So drop NA in place true. So if we delete all these, now is null.sum, so then we do not have any null values. Sample only 10,000 data points as we discussed in the initial steps, so points from the used data set, right? Now to make it a basic example so that you can better understand with this. Now df sampled equals to df composer dot sample n equals to 10,000, random state equal to 98, df sample dot head, so this is the head that we have, df sample dot save 10,000, right? And then 3, that's save. Now we are applying, of course, the content based recommendation system. So as I said, you will apply in the song recommendation the content based recommended system. Now we will create a document from frequency matrix using tfdf on the composer column. So tf equals to, again we are calling the tfdf vectorizer, analyzer is word, n-gram range we are passing 1 to 2, minimum df0, stop words in English. Now tfdf matrix, so tf dot fit transform df sampled composer, so tfdf matrix dot shape, so this is the shape we have. We calculate the cosine similarity for tfdf matrix we generated using tfdf vectorizer. Cosine similarity equals to linear kernel, so again we are passing a and b values to get the cosine similarity. So cosine similarity we get it the shape. Now df sample dot head, so we have song ID, name, composer in this way. Now df sampled equals to df sample dot reset index. Okay, df sample dot head, so index, song ID, name, composer, that is the head. Now titles df sampled name, okay, and indices df series df sample dot index df sampled equals to name. So we create an indices data frame which will give the index of the song given the song name. For example, indices dot head, so we have this song name and the index number. Now this function take in a song name as an argument, find its index, then it gets a list of all similarity score for the song index, then it sorts the similarity scores from highest to lowest and takes only the first 30 scores and returns the song name for these indexes with highest score. So we are defining get recommendations name, so idx equals to indices of name, SIM score, so we are taking a list of enumerate cosine similarity of these indexes. Similarity score, we are sorting it on similarity scores, key equals to lambda, applying the lambda function of all these x on first values. Now reversing equals to true, similarity score, similar score of 1 to 31, music indexes I of 0 for I in similarity score, and returning the title. Now if we call this function by passing any song, it will return the recommended songs, right? So let's see how it will work. So get recommendation author day in paradise dot head, right? Dot head of 5. So first we call this function by passing this value, and we need only first 5 values. So these are the similar song that is suggested by the this function. Okay, now get recommendation of this song head 6 head 10. So these are the recommendations, these are the content based recommendation based on this song name. Now finally, if we conclude or interpret the song recommendation system, so we have successfully built a content based song recommendation system engine using 10,000 songs from the entire data set of song that was available to us. I hope this video helped you a lot, and I hope you learn the EDA on dealing with missing data. You knew the content based recommendation system, how we can apply this and how we can get the inside of it, and then time frequency inverse document frequency, or that is TFDF. So I hope this video helps you a lot, friend. If yes, please do like, share and subscribe, so that will motivate us or my team to work more on these content, and will be coming with new content as well, whether it is recommendation system or the upcoming playlist. So stay tuned. All the best till then. Have a good time. Thanks.